Hello everyone, and welcome back to our little corner of the internet. It's your host, ichino-ani. Today is August 25th, a lovely Monday, and I found a really neat article from the archives for us to explore together. It's from the world of machine learning, and it has a very long title. Are you ready? It's called Discovering Hidden Algebraic Structures via Transformers with Rank-Aware Beam GRPO. Phew, that's a mouthful, isn't it? The query also a bit of a code. chaps://crackfork.org/abs/2508.50.50,007. It sounds super complicated, but I promise the idea behind it is really cool. Like solving a mystery. So let's break it down together. Imagine you have a giant, super duper complicated Lego castle. You can see the final castle, but you have no idea what smaller Lego kits we used to build it. The problem this paper is trying to solve is just like that, or with math equations instead of Legos. It's called functional decomposition. You start with a really long and messy math equation. Let's call it f. The goal is to figure out if this messy equation f was actually by combining two or more much simpler equations. Let's call them g and h. The tricky part is, once you combine g and h to make f, the original simpler pieces get completely hidden. It's like mixing blue and yellow paint to get green. It's really hard to see the original blue and yellow anymore. This problem is so hard that computer scientists call it impaired. That's a fancy term that basically means it's incredibly difficult to solve, especially as the equations get bigger and more complex. There's no simple, quick recipe to find the answer. So what did these clever researchers do? That they decided to teach an AI, a transformer model just like the ones that power chatbots, to become a math detective. First, they needed a way to teach it. They did something really smart. Instead of giving the AI the hard problem first, they worked backward. They started with the simple equations, g and h, and combined them to make the big messy one f. And they showed the AI both the messy equation f and the simple answers g and h. It's like teaching a child to solve a maze by first showing them the path from the finish line back to the start. They did this millions of times to create a giant textbook for the AI to learn from. Now, even with all that training, the AI had a specific problem. It was pretty good at figuring out the general shape of the simple equations, but it kept getting the plus and minus signs wrong. It's a tiny detail, but in math, one wrong sign makes the whole answer incorrect. To fix this, they used a technique called beam search. Think of it like this. Instead of the AI just picking the one answer it thinks is best, it keeps a few of its top guesses active, like exploring a few different paths in a forest at the same time. This way, it could try out different combinations of plus and minus signs, and was much more likely to find the correct path, but that was still a bit slow. So, they invented a new method to make the AI even smarter and faster. They called it beam grouped relative policy optimization, or BRPO. I know, another long name, but the idea is simple. It's a form of reinforcement learning, which is like training a puppy with treats. When the AI finds the right answer using its beam search, it gets a reward. And here's the really clever part, the Rank-Aware bit. The AI gets an even bigger reward if it finds the correct answer in its first or second guess, instead of its 10th guess. This teaches the AI to not just find the right answer, but to find it quickly and confidently, and it worked wonders. This new BRPO method helped the AI get the same accuracy, while using about 75% less computer power during inference. That's a huge jump. So you might be thinking, okay, ichino-ani, that's a neat math trick, but how does this help us, daily lives? Alright, great question. This is some amazing applications. First, let's think about the electronics we use every day, like our smartphones and computers. The tiny chips inside them have super complex circuits. Well, designing these circuits is a lot like functional decomposition. By breaking down a complex function into simpler parts, engineers can design smaller, faster, and more power-efficient chips. This research could lead to even more powerful gadgets in the future. Second, let's talk about keeping our information safe, which is called cryptography. Many of the codes that protect our emails and online banking are based on math problems that are easy to do one way, but almost impossible to reverse. Just like our polynomial problem, are getting better at solving these hidden structure problems. Researchers can test how strong our current security is, and even help design new, unbreakable codes to protect our privacy, and for a third example, think about robotics. A robot arm's movement is controlled by a set of very complex equations. If we can decompose these equations into simpler parts, it becomes much easier to control the robot's motion smoothly and accurately. This could help in manufacturing, where robots build cars, or even in surgery, where robotic arms need to make very precise movements. Now, for the most exciting part, how does this AI compare to existing tools? The researchers tested their model against a very powerful and famous math software called Mathematica. Ladder. That was like the world champion of solving math problems on a computer. And guess what? In several tests, this new lightweight AI model was able to simplify complex equations, even better than Mathematica by full simplify function. That's incredible. It means these AI models are not just memorizing patterns, they're learning to understand the deep, hidden rules of mathematics, sometimes in ways that even our best tools haven't found yet. So, to wrap it all up, this paper shows us that transformers can be taught to solve incredibly hard abstract math problems by finding hidden structures, and with clever training methods like GRPO, they can do it efficiently. This opens up a whole new toolbox for scientists and engineers to help design better electronics, stronger security, and smarter robots. So a wonderful reminder that there are always new, hidden patterns to discover. And sometimes a new way of looking at a problem is all you need. That's all for today, everyone. Stay curious, and I'll see you next time. Bye-bye.